So let's go ahead and balance some chemical equations. In A, we have N2, nitrogen, H2, hydrogen, combining to form NH3, which is ammonia. Now, if we follow the rule, we should balance elements that appear most often last. Well, each one appears twice, so we can't follow that one. And generally speaking, that one is a secondary rule. I always focus on number 2 first, where we deal with the largest molecules. Largest molecule is NH3. We have nitrogen and we have hydrogen in it. Taking a look at the nitrogen on the left as it stands, we have 2 nitrogen atoms on the left, but only 1 on the right. When we have NH3, that means we have 1 nitrogen and only 3 hydrogens. So we need to make those nitrogens balance. I can do that by putting a 2 coefficient there. Now I have 2 nitrogens. Continuing to balance with NH3, now my hydrogen count is 6 because we have 2 times 3. We only have 2 hydrogens on the left, but I can make that 6 if I put a 3 coefficient, because 3 times 2 will give me 6. That actually balances off everything. So we don't even need a coefficient on the nitrogen, but as I said, it's really to put a 1, at least when we're balancing. That way we know that we've looked at it and it hasn't just been left blank. In B, if we look for the biggest molecule, you might be tempted to think that it's S8. Well, it is a large molecule. It consists of 8 sulfur atoms, but it's also an element that's by itself. So in the grand scheme of things, it's not quite as big as something as SO3. Even though SO3 has fewer atoms in it, because it's a compound with more than one element, it's easier to balance it off first. So looking at SO3, we have 1 sulfur atom in that compound on the right, but 8 sulfur atoms in S8 on the left. So to balance that off, I need an 8 on my SO3. By doing that, I've now created 24 oxygen atoms. 8 times 3 is 24. In order to make 24 oxygen atoms on the left, I can put a 12 coefficient on my O2. 12 times 2 is 24. And we've balanced both the sulfur and the oxygen. So just to show that we've looked at it and we've considered it, 1 on the S8. C is a little more complex. We have zinc, we have hydrogen gas as elements by themselves. We also have HCl and ZnCl2. In terms of biggest molecule, that would be ZnCl2. So if we balance it off, in ZnCl2 we have 1 zinc. We also have 1 zinc on the left. In ZnCl2 we have 2 chlorine atoms, but only 1 on the left. So if I put a 2 on my HCl, that'll balance off my chlorines. The only other element that's present in this reaction is hydrogen. Looking at it, we now have 2 hydrogen atoms on the left because of the 2 HCl. We also have 2 hydrogen atoms on the right because it's H2. So very simple to balance this one. Everything is balanced. We'll fill in 1s and be done. Another more complicated equation in D. Looking at the elements by themselves, we have sodium on the left, hydrogen on the right, so we'll leave those ones till the end. We also have H2O and NaOH. Both of those compounds have 3 atoms in them, but I'm going to consider that NaOH is actually more complicated because it's 3 different atoms instead of H2O, which is 2 different atoms. So looking at NaOH, we have 1 sodium in that compound. We also have 1 sodium on the left, so we're okay. We have 1 oxygen in NaOH. We also have 1 oxygen on the left, so we're okay there. But the hydrogens, these actually create a bit of a problem here because hydrogen shows up in 2 compounds. The way it sits right now, if we look at the hydrogens on the right, we have 3 of them. 1 from NaOH and 2 from H2. We also only have 2 hydrogens on the left, which complicates things. In order to turn 2 into 3, we'd have to multiply by 1.5, which is not okay. We can only use whole numbers when we're dealing with balancing chemical equations. So knowing that I have 2 hydrogens on the left, and whatever I multiply that by is going to result in an even number, I need to know that I'm going to have an even number of hydrogens on the right. If I put a 2 with my NaOH, then I've accomplished that. That does unbalance just about everything else, so we need to go back and reevaluate. We're now at 2 sodiums on the right. If I can make 2 sodiums on the left, that balances off the sodiums. By changing the coefficient on NaOH, we have 2 oxygens on the right. Need to make 2 oxygens on the left. If I put a 2 here, I'm okay. Looking at hydrogens now, I have 4 hydrogens on the right. 2 from my NaOH, 2 from my H2. I have 4 hydrogens on the left. So I'm okay. Fill in a 1, and we're good. This is one of the more difficult equations to balance, just because of the fact that hydrogen appears in multiple compounds. E may be the biggest molecules we've seen yet. Definitely the biggest molecule here is C10H16. So if we look to balance that, we have 10 carbons on the left. I need 10 carbons on the right. Coefficient of 10 will do that. I have 16 hydrogens on the left. I need 16 on the right, so a coefficient of 16 on HCl will do that. My chlorines, I have 2 on the left, but now I have 16 on the right. I need to get back to 16 on the left if I put a coefficient of 8, because 8 times 2 will give me 16. Put a 1 in C10H16 and we are good. In F, our big molecule is Al2O3. 2 aluminums in that molecule. I need 2 aluminums on the left. I can put a 2 coefficient. 3 oxygens in Al2O3. I need 3 oxygens. I can do that by putting a 3 in front of my FeO. The only other element that I haven't considered is the iron, the Fe. I now have 3 irons on the left from 3 FeO. I can make 3 irons on the right quite easily, and everything's balanced with a 1. G, not that dissimilar to E. Large molecule be C7H16. 7 carbons in that molecule. I need 7 carbons on the right. If I have 7 CO2, I'm good there. 16 hydrogens in C7H16. So to make 16 hydrogens on the right, I can put an 8 on my H2O. 8 times 2 is 16. I haven't considered oxygen, but it shows up as an element by itself on the left, so that makes it easier. I do have oxygens in 2 compounds on the right, so that does create a little bit of a hiccup. I have 14 oxygens from my 7 CO2, 7 times 2. I have 8 oxygens from my 8 H2O, so I have actually 22 oxygens on the right-hand side. To make 22 oxygens on the left, I can put an 11 as my coefficient on O2. 11 times 2 is 22. 1 C7H16, and that equation is totally balanced.